Welcome. Giving continued integration using trigonometric identities, we have seen why we use this kind of integration, and we have also seen some of the basic trigonometric identities. Now, we use these trigonometric identities whenever we cannot apply directly u dv and we have two trigonometric functions that are multiplying with each other. So in that case, you cannot apply the other forms. So what do we do here in trigonometric identities? We convert one of those functions or one of those expressions into its equivalent trigonometric identity, and then we can apply all the other methods we know. For example, we can apply integration by parts. We can also apply integration by substitution, also called u du. And we had this example here. It was sine raised to 4 x cos raised to 5. It was cos raised to 3. This was cos raised to 3 dx. This was what was given to us. Now, in order for us to continue with this, we have to decide which one are we going to use its equivalent identity. We have sine here and we have cosine. So there is a rule also called MN rule. So what it basically tells us is that we have to find whichever is that expression, this is cos of x, that expression that has an odd power or odd exponent. And then we are going to find trigonometric identity with respect to that given function. In this case, we have two. One is sine raised to 4, another one is cosine raised to 3. So this cosine raised to 3 has an odd exponent or odd power. So it means that our trigonometric identity should be with respect to cos of x. So we have this cos square of x is equal to 1 minus sine square of x. So this is the trigonometric identity that we are going to apply, because this is odd and is on the power of cosine. So what we do is this. So we're going to have here sine raised to 4 of x, and then cos cube. It means what? It means it is cos square of x into cos of x dx. So basically what we did is that we just expanded this so that we can have our cos square of x evident here in this function. So if you multiply this again, we're going to have cos cube, and then we're going to continue. Why did we do that? Because we want to replace this. So this is going to give us sine raised to 4x. Instead of this cos square of x, we are going to use its equivalent expression or identity. It's going to be sine square of x into cos of x dx. Done. Great. Now we want to continue with this. If you see, in this case here, now we can use our substitution u du. If we take our sine of x as u, the derivative of sine is cosine, so we're going to have here cos of x dx. So it means we can use our substitution u du. So we're going to have here u is equal to sine of x. It means that du is equal to cosine of x dx. We cannot take cos of x as u because you're going to have sine raised to 4 dx, which is not possible in this case. You cannot have that expression. But if we take sine of x, we can have cos of x dx, because there's no power here, so it's fine for us. We're not going to have any power on du. Fine. Now continue with this. We're just going to replace it. Now our function is going to be expressed in terms of u. So we're going to have, instead of sine raised to 4, it's going to become u raised to 4. Okay, u raised to 4 into 1 minus sine. It's going to become u square, like this. And then here we're also getting cos of x dx, which means du. So this is what we get here. So this is going to become this. We are distributing. So this is going to become u raised to 4 minus u raised to 6 du. Fine. And this case is the case of the power rule. So what you do when you have a power rule, you basically have to take whatever you have, increase 1, divide by that same power, then minus u raised to 7 divided by that given 7. Fine. But our function is in terms of sine and cosine, so we don't want u. So So we're going to say it is equal to, instead of u, we're going to put here sine raised to 5 of x divided by 5 minus sine raised to 7 of x divided by 7. But this here, as you can see here, it has no limits of integration, so this is going to have our constant c. Done. This is case number 1. Now let us consider another case in which we have here, let us say this is case number 2. We're going to have here, instead of this expression, let us say I have cos raised to 4 sine raised to 5 of x cos of x dx. So in this case here, what we have to do, let us write it again here so that it's clear. Of x, this is raised to 4 and this is sine raised to 5 of x dx. Now in this case again, what we have to see, we have to check the exponent of these two functions. We have this function and we also have this function here. Then we have to check which one is an odd. This one is odd, which means that we're going to find out trigonometric identity with respect to sine. So it's going to become sine square of x, this is the trigonometric identity we're using, is equal to 1 minus cos square of x. Done. So the next thing we have to do is that we have to try to find a way to put this into this expression. So this is going to be integral of cos raised to 4 x into sine square of x. We managed to put it already here, but this is raised to 5, so if you put here raised to 2, this and this is going to become 4, so we need one more sine of x here outside. Done. This is our expression. Now we have to replace with the identity for x. Instead of sine square of x, we are going to have 1 minus cos square of x, all this square, into sine of x dx. Fine. In this case here, what can happen again is that we can apply our substitution u du. If you take u as cos of x, then we're going to have derivative is going to be minus sine of x. So we are going to take u, which is equal to cos of x, and du is equal to minus sine of x dx. But as you can see here, we don't have minus sign, so this means that minus du is equal to sine of x dx. Fine. So continue with this thing. We are going to have here integration of cos becomes now u raised to 4, and then we are going to have here 1 minus u square minus du, which is this part over here, minus du. Great. So this minus sign can come outside. We're going to have minus. We're going to have here u raised to 4. Then we have here this expression 1 minus u square, all these things squared. Then we have to expand this thing. And if we expand this thing, what we're going to get here is this becomes 1, this becomes minus 2 times plus square, yes. So then becomes u4 du. Fine. This is the expression we get here in terms of u. So to make it easy for us to solve, what we're going to do is just distribute this u here. So this is going to give us, let's continue from here, this is going to give us minus sign, then our integration, then you're just distributing this u inside here. So we're going to have here u raised to 4 minus 2 u raised to 6 plus u raised to 8, all this is du. Then this is going to be equal to basically the individual integration of all of this. So we're going to have here u raised to 5 divided by 5, but because this minus sign becomes minus, so minus u raised to 5 divided by 5, minus becomes plus 2u raised to 7 divided by 7, and then minus u raised to 9 divided by 9. Great. But our function is not in terms of u, our function is in terms of x, sine of x. So it's going to become this is equal to minus, instead of u cos, we're going to have here cos raised to 5 of x divided by 5 plus 2 cos 7 of x divided by 7 minus cos 9 of x divided by 9. And because you can see we don't have boundaries here, limits of integration, this is going to give us plus c. And then we have found our solution.